Welcome back to the course, Multi-Layer Neural Network Training and Testing Implementation. This is Lesson 8, where we will do a quick review of the mathematics of training. A neural network consists of L neuron layers indexed from 0 to L-1. Each layer L has a matrix of connection weights labeled W superscript L, a neuron bias array labeled B superscript L, an activation function labeled alpha superscript L, and an output array labeled A superscript L. The first layer, layer 0, is connected to the N inputs. The last layer produces the M outputs of the neural network that can be compared to the M targets for a given input array. This is an arbitrary neuron K in layer L. The inputs to the neuron in this layer are the outputs of the previous layer or the inputs to the neural network. Each input has a corresponding weight labeled W superscript L sub K, comma J. Each neuron also has a bias value labeled B superscript L sub K. The neuron's net value array is calculated by summing the multiplications of the inputs and their corresponding weight and adding the neuron's bias. The neuron's output array is calculated by passing the net value through the layer's activation function. Each layer can have its own activation function labeled alpha superscript L. These are the 4 steps involved in the training of a neural network. Step 1 of training is the feed-forward processing of the inputs. The input array X is processed through all the layers of the neural network to produce the output array Y. Every layer L performs the calculation shown in the previous set of slides to calculate the layer's output array labeled A superscript L. The first layer processes the input array X. The last layer produces the neural network's output array Y. Step 2 of training is the computation of the prediction error. The prediction error is some difference between the output array Y and the target array T. Usually, the error is the simple difference between T and Y, or the squared difference between T and Y. Step 3 of training is the backpropagation of errors. Starting with the last layer of the neural network, using the error array calculated in Step 2, the signal array, denoted by S superscript L, is calculated by multiplying the previously computed error array for the layer by the derivative of the activation function for the layer using the output array of the layer as parameter. The error array, which will be backpropagated to the previous layer, is computed by multiplying the transpose of the current layer's weight matrix by the current layer's signal array and is then backpropagated to the preceding layer to continue the process. Step 4 of training is the gradient descent, which involves updating each layer's weight matrix and bias array. A layer's weight matrix is updated by adding to the current weight matrix the current deltas plus the previous deltas multiplied by the momentum parameter. The current deltas are calculated by multiplying the gradient matrix by the learning rate. The gradient matrix is calculated by multiplying the signal array by the transpose of the layer's input array. The layer's bias array is updated by adding to the current bias array the current bias array deltas plus the previous bias array deltas multiplied by the momentum parameter. The current bias deltas are calculated by multiplying the bias gradient array by the learning rate. The current bias gradient array is equal to the layer's current signal array. This concludes the course, Multi-Layer Neural Network Training and Testing Implementation.